Here's a fun fact. Because the moon can eclipse the sun so perfectly, we can measure the constituency of the sun, the materials and elements on its surface, by observing the pinkish arc of the chromosphere at the moment of totality.
Here's a fun fact. The only reason we cannot observe the elements on the surface of the sun all the time is because we live under an atmosphere. Without this, you could make exactly the same observations you can during an eclipse simply by putting your finger over the body of the sun. Here's a fun fact. If we could actually see in the H-alpha wavelength, we would be able to directly observe the dynamic behavior of the surface of the sun. Here's a fun fact. Have you ever wondered why there isn't an eclipse every time the moon orbits the Earth? Well, it's simple. The angle between the plane in which the moon orbits the Earth to the plane in which the Earth orbits the sun is about 5 degrees. Practically, this means that a total solar eclipse can only happen at 2 times of the year. In a different geometrical arrangement, such as, say for instance, the moons of Jupiter, an eclipse is observed every time the moon goes around the planet.
The moon fits over the sun so perfectly that it makes it possible to observe the surface of the sun. Otherwise, this would be impossible. If the moon was too big or too small, it would be impossible. Because of our vantage point from the Earth, the moon fits perfectly over the sun, the chances of which are 1 in a trillion.
What a crock of shit. The distance between the Earth and the moon varies by about 10%, between about 360 and 410 million meters. This practically means that the angular size of the moon can vary by about 10%. As a direct result of this, about 60% of non-partial eclipses, the moon is too small to completely cover the sun and an annular eclipse is observed. In the remaining 40%, the moon is too large and a total solar eclipse is observed. All that is required to observe the outer layers of the sun is for the moon to be angularly bigger than the sun. Further, it's completely bogus to call this perfect, for the simple reason that the moon does not have a smooth surface. This causes an effect known as Baily's beads, where the sun shines through the valleys of the surface of the moon.